Social media recommendation algorithms are designed with a single, clear objective: maximize engagement. To keep us watching, these systems have learned that extreme content, the stuff that triggers our strongest emotional reactions, is far more effective than balanced information. This optimization loop creates a filter bubble. By repeatedly serving users the same polarizing viewpoints, the algorithm unintentionally accelerates the spread of unverified claims and undermines public trust in shared facts. This chart highlights the friction point of the modern era. While human institutions grow at a steady, linear pace, Ray Kurzweil's law of accelerating returns suggests that technology is riding a curve of exponential growth. As this acceleration continues, we move from simple video recommendations to high-stakes autonomous systems. Researchers are now looking toward the possibility of sentient AI, systems that perceive the world with enough complexity to give rise to what may be considered subjective experience and self-awareness. The core vulnerability is one of speed. Machines are learning and iterating using vast datasets at a non-linear rate, while our laws, ethics, and schools are still trying to catch up using institutional tools designed for a slower century. We are losing our grip on technological control. Our foundational systems were simply never built to adapt to the speed of machine evolution. In the early years of computer science, humans hard-coded every rule. This evolved into machine learning, where we provided the data and allowed algorithms to categorize it based on patterns they identified independently. Deep learning represents a massive leap in complexity. By using artificial neural networks that process fair data that is findable, accessible, and interoperable, these systems identify relationships between concepts that are completely invisible to the human eye. This is the black box. When an AI system delivers a medical diagnosis or a judicial recommendation, it relies on millions of hidden calculations. We see the input and output, but the internal logic remains a mystery to its creators. Explainable AI techniques like LIME and SHAP analyze internal node weights and pathways to identify the exact data points that influenced a decision. These transparency tools only work if there is a human on the other side capable of interpreting them. We cannot monitor systems we do not have the technical literacy to understand. We are facing a critical human bottleneck. At the exact moment advanced technical comprehension is required to manage autonomous systems, global public investment and worker training is actually declining. To close this gap, we have to move past traditional models of education. Rote memorization was designed for an era where information was scarce, not for a world where AI can recall any fact in milliseconds. We must prioritize a new set of human cognitive skills. This means focusing on creativity, on systems thinking, and continuous lifelong learning, allowing us to adapt as quickly as our software. This scientific literacy is vital for governance. Policymakers need a deep understanding of AI to create adaptive regulations and dynamic consent models that allow citizens to adjust how their data is used over time. Managing the AI revolution requires an upgrade to human cognition itself. We must iterate our understanding of the world as rapidly as the machines we built. By 2030, AI will be the primary engine of healthcare. These systems will analyze individual genetic profiles and medical histories to design personalized treatment plans and accelerate the discovery of new antibiotics. This transition is driven by the sheer volume of information available. The digital data stored by humans already far exceeds the total genomic information of every person on Earth. We are already trusting digital algorithms to manage our safety via autopilots and our reproduction through online pair bonding. From an evolutionary perspective, this integration of technology and biology represents a transition in information processing as significant as the development of DNA itself. For the modern workforce, the reality is stark. The lifespan of a static, unupgraded skill is rapidly shrinking to zero. In a society dominated by hyper-intelligent systems, our most valuable survival trait is the ability to continuously reinvent ourselves. To thrive in the era of artificial intelligence, we must ensure that human intelligence becomes just as dynamic, expansive, and adaptive as the machines we have created.